Well, we made it to the end, so I just want to leave you guys off with some final thoughts. On larger projects, you don't want to recompile all the code each time you make the change. First, make sure that you have the object files of everything using the command gcc-c*.c. The -c specifies to the GCC compiler that it should create all the object files but not link them. After the object files are created, you need to run the gcc-o file *.o, which will link all of the generated .o files. The compiler will skip most of the compilation process and will begin linking them together to form an executable. If changes are made to a single file, you'll only have to recompile that one file using the -c option outlined previously. Of course, specifying your file name instead of using the asterisk symbol. You will have to link all the files again to create the executable, but it's a drastic reduction in compilation time. You can automate this process using the make build automation tool. When you need to allocate memory at runtime, you'll use the malloc function. Malloc takes a single parameter. That parameter tells the malloc function how many bytes to allocate on the heap. Since most of the time you're not gonna know how many bytes you'll need, the malloc parameter almost always utilizes the sizeof operator. To be able to use the malloc function, you'll first need to import the standard library.h library file. Once the memory has been allocated on the heap, the malloc function returns a general purpose pointer to the newly generated space. Although it's not necessary, most programmers will cast the general purpose pointer to a specific data type. Programmers should always use the free function to deallocate memory on the heap. If not, there's a possibility that a memory leak may occur. If a memory leak does occur, you can use a Linux utility like valgrind to locate it. Valgrind has its own versions of the malloc and free functions. It will intercept your code and keep track of the code that calls for heap allocation and deallocation. Valgrind works best if your compiled executable contains debug information. And to add debug information to your code, use the -g option with GCC. Fun fact, if you look up the definition of heap, it's an untidy collection of things piled up haphazardly. The heap in memory is called a heap because it stores data in an unorganized way.